Welcome to the first in a series of videos overviewing Hyperflux's core functionality. This first video will go over our ORL ingestion engine. This engine is designed to let you feed an ORL or other requirements document into our AI backbone and extract requirements per NCOSI standards and automate loading them into your requirements tool. Let's get started. Okay, so we're going to be continuing our Hyperflux series. We've created a new project that was blank with no connections. We're calling this systems pod var. We're going to be focused on systems integration for this one. So we're going to create a new connector for uh, doorstop as well as Papyrus. We use doorstop for requirements management, and Papyrus is our SysML tool. So all I need to configure doorstop is I need my remote path. I need my container mount path, which is my default. My prefix, I'm gonna leave it as I'm gonna change it to be SV, and I'm giving it 3 digits to count. I'm not filling out my host configuration because that's my default. Now I have my doorstop configured. Okay, so now I need to create my SysML connection, which in this case we're using Papyrus. So I'm adding a new Papyrus connection, and I need to configure my remote path, my workspace path, my container, and my container's workspace path. This is all pretty easy to do. All I'm doing here is really just pointing my connector to my model and where my data is, and that's my configuration for this. So now I am going to go into my requirements tab. I'm going to add an ORL document. Before I do that, let's look at that ORL. So anybody that's worked in engineering for a long time knows these are typical kind of documents we get from customers. Sometimes they're really, really good, but most of the time they're really, really bad. So we have some TBDs in here. We have some requirements that are buried in text. We have a mixture of tables. We have some should statements instead of shalls. So let's see how good our AI does at extracting these requirements for us. So I'm just going to leave it as auto detect. I could put in a thing here, but I'm not going to. So my output. So for the output directory, we need to set that for our project, which is here. And then I'm going to go ahead and click extract. And you see that it's starting to look at the document. This is going to take a while, so I am going to actually uh, cut the video out and then come back later. For a document this size and the complexity, this is probably going to take an hour or two. So I'm not going to make you waste looking here at the screen. But what's it doing? It's going through two different paths. The first pass is to go look through and understand the document. And then the second pass is going to go and extract what it believes are requirements. And then, it'll apply a little bit of domain knowledge, and then submit proposals for me to approve, to put those into my requirement systems. So we will pick up the video back here in a little bit once this is done. Okay, here I can show you that there is actual progress going on, just to give you an update. As I mentioned, this does take a while. I'm using an A10 GPU on a AWS cloud server for this demonstration. So it takes a little bit. It would run about twice as fast if I was using the RTX 3090 or something more powerful locally. But as you can see, we are progressing. I'll be back in a little bit. So, okay, our extraction is finally done. We can see we went through 23 sections of a document. We had 76 requirements. We had an average confidence of 88%, uh, low quality confidence of 48% for 15 of our requirements. Um, so it took the model an hour and 26 minutes to extract these requirements and give us a confidence score. We can look at the details of each requirement and see which ones it scored as low confidence. So those are the ones we probably want to look at with a good human eye review, and we can see which ones are high confidence. So we can see a pretty good metric and understanding of which requirement came out as what, and they're automatically assigned domains and a type, i.e., an environmental requirement versus an interface requirement. And then we can do commit these all to doorstop, put my name in here. That gives me my cryptographic signature. And I can put some notes that, so I'm telling my team to look at all the requirements, and I can't spell tonight. And then I'm going to sign and commit all. All of these will go to my doorstop requirements database. And then I can go through and I can keep this, or I can take a screenshot of this chart, or I can extract this chart. And then I have a good basis to start my discussion with my team of what requirements are good and what requirements are bad. Okay, this is a little post analysis of the requirements generation from the ORL. This is not a report that currently exists, but I am going to put something like this into the code. So we get a summary that basically matches what you saw on the screen, tells us how many requirements we got, where they are, confidence score, what's got the lowest quality. You can actually go to the quality analysis tab. That's basically creating that graphical that was shown that gives you quality of high, medium, or low, and gives you the confidence score. You can go look at each individual requirement, but these trace. So if I was to go look at a low quality requirement, so like requirement 03, I can go right into requirement 03, and I can look at see what's possible wrong with it. So then it gives, and that way I can know, hey, I might need to work on this a little bit. Um, but that's the ORL extraction in a nutshell. This currently works with doorstop. I don't see why it couldn't work with doors or the various other requirements management tools. And that's how Hyperflux extracts requirements. My next video will be showing how we automatically generate UML, SysML data using these requirements and other information that we provide to Hyperflux.